This is today's number 4 most urgent vulnerability on the Daily Ranked CVE Brief, where we rank what to patch first using real exploitation signal. CVE, first EPSS, and CVSS. The issue is CVE 2026-34197 in Apache ActiveMQ. It is not a theoretical, someday bug. It is listed in CISA's Known Exploited Vulnerabilities catalog, and its EPSS percentile is 0.99876, meaning it sits extremely high compared with other vulnerabilities for predicted exploitation activity. The short version: an authenticated attacker who can reach the ActiveMQ web console's Jolokia endpoint may be able to turn management functionality into arbitrary code execution on the broker's Java virtual machine. If ActiveMQ brokers are part of your messaging backbone, this is the kind of flaw that can become an infrastructure-level incident. CVE 2026-34197 affects Apache ActiveMQ Broker, Apache ActiveMQ All, and Apache ActiveMQ, according to the published description. The vulnerable area is the ActiveMQ Classic Web Console exposing the Jolokia JMX-HTTP bridge at /API/Jolokia. Jolokia is used to expose Java management operations over HTTP. In this case, the default Jolokia access policy permits exec operations on ActiveMQ mbeans under org.apache.activemq. The weakness categories tell the story. CVE 20, improper input validation, means the software accepts something it should constrain or reject. CVE 94, code injection, means attacker-controlled input can influence code generation or execution. CVE 78, operating system command injection, reflects the possible consequence: execution of commands in the environment where the broker is running. Verdict: 8.8 high is the right level of urgency because this is network reachable, low complexity, and can fully compromise the broker once the attacker has required access. The two CVSS metrics that matter most here are attack vector and privileges required. Attack vector is network, so the vulnerable interface can be reached remotely over the network if exposed. Attack complexity is low, meaning exploitation does not depend on unusual race conditions or fragile environmental timing. The important limiting factor is that privileges are required. This is not scored as a no-login internet drive-by. But do not let that lower your concern too much. Many incidents begin with stolen credentials, reused admin passwords, overly broad console access, or exposed internal management planes. The impact metrics are high across confidentiality, integrity, and availability, which means a successful compromise can affect data, system behavior, and uptime. The reason this lands at number 4 today is the exploitation signal. CVE status means the vulnerability is in the Known Exploited Vulnerabilities catalog. That is a major prioritization marker, because it moves the conversation from "could this be exploited" to "defenders should assume exploitation is relevant." Pair that with an EPSS percentile of 0.99876, and the patching case becomes very strong. ActiveMQ often sits in the middle of application workflows, moving messages between services. If the broker's JVM is compromised, the risk is not limited to the web console itself. An attacker may be positioned near message traffic, internal service connectivity, credentials available to the broker process, and operational controls. Even when ActiveMQ is not internet-facing, a compromised internal account or adjacent system can make this reachable. Conceptually, the attack path starts with authenticated access to the ActiveMQ web console area that exposes Jolokia at /API/Jolokia. From there, the vulnerable condition involves management operations on ActiveMQ mbeans, including operations named in the description: brokerservice.addNetworkConnector and brokerservice.addConnector. The published description says an authenticated attacker can invoke these operations with a crafted discovery URI that triggers the VM transport's broker config parameter to load a remote Spring XML application context using resource XML application context. The key defensive idea is this: configuration is being processed before the broker validates it safely. Spring instantiates singleton beans before broker service validates the configuration, and that creates the window where arbitrary code execution occurs on the broker's JVM. We are not walking through exploitation, but defenders should understand that this is management plane functionality being turned into code execution. Start with inventory. Find every Apache ActiveMQ broker or Apache ActiveMQ deployment, including systems embedded in products are managed by application teams rather than the central platform team. The description states that affected versions are before 5.19.4 and from 6.0.0 before 6.2.3. Across Apache ActiveMQ Broker, Apache ActiveMQ All, and Apache ActiveMQ. Use the vendor advisory as the source of truth for exact applicability in your environment, especially if you receive ActiveMQ through a distribution or appliance. Next, check whether the web console is enabled and whether the Jolokia path is reachable from user networks, VPN ranges, jump hosts, or the internet. Then review who can authenticate. This vulnerability requires privileges, so account hygiene and management console access control are central exposure questions, not side issues. The primary fix is to upgrade to version 5.19.4 or 6.2.3, which the official description says fixes the issue. If you maintain multiple ActiveMQ lines, make sure each deployment is mapped to the correct fixed version. While patching is planned, reduce exposure immediately. Restrict the web console and Jolokia endpoint to trusted administrative networks only. Remove broad access from general internal subnets. Review ActiveMQ console users, especially shared accounts, dormant accounts, and accounts with administrative privileges. Rotate credentials if there is any doubt about past exposure. Put management access behind strong authentication and normal administrative controls. Also review whether the broker process has more operating system privileges than it needs. Least privilege will not remove the vulnerability, but it can reduce blast radius if something goes wrong before patching is complete. For detection, focus on management plane behavior. Review web access logs for requests to /API/Jolokia, especially from hosts that are not normal admin workstations or automation systems. Look for unusual authenticated activity, repeated failures followed by success, or access outside normal maintenance windows. Where logging captures Jolokia or JMX operation details, pay attention to exec operations against org.apache.activemq mbeans, especially operations related to adding connectors or network connectors. On the broker itself, monitor for unexpected configuration changes, new connector definitions, and outbound network connections from the broker process to unfamiliar locations. Because the described impact occurs in the broker's JVM and mentions runtime.exec as a possible bean factory method, process monitoring should also flag the Java broker process launching unexpected child processes. Normal should be boring, known admins, known automation, planned changes, and predictable broker network behavior. Bottom line, CVE 2026-34197 is an Apache ActiveMQ vulnerability where authenticated access to Jolokia exposed management operations can lead to arbitrary code execution on the broker's JVM. The CVSS score is 8.8, high, but the ranking is driven by more than score alone. CISA-KEV is true, and the EPSS percentile is extremely high. If you run affected ActiveMQ versions, upgrade to 5.19.4 or 6.2.3, verify console exposure, tighten authentication, and monitor for unusual Jolokia and connector activity. This is the Daily Ranked CVE Brief, what to patch first, ranked by real exploitation signal every day. Subscribe if you want the next prioritized breakdown, and check the full ranked report linked in the description.